Hey everybody, welcome in. Really excited that you've joined us today. Just going to give everybody a few moments to filter in and we will get started in just a few. Thanks for your patience. If you are just entering in, welcome. Just going to give everybody one more minute to come into the meeting and then we will get started. Alrighty, looks like we are good to go. Thank you so much everyone for joining us. Really excited you're here. I'm going to turn it over to our presenters now.
Hey everybody, thanks for joining us today. My name is Stephen Lincoln and with me is Joe Mastromarino. What we're going to be doing today is presenting how we've incorporated Sigma into the AttackIQ platform and also kind of go over a brief introduction, both beginner, kind of intermediate and advanced usage of Sigma. So this should have kind of something for everybody, whether you're very familiar with Sigma or not familiar at all. So just to introduce myself really quickly, my name is Stephen Lincoln. I'm a security engineer at AttackIQ. I've been with the company since November of 2021. Overall, I have over 12 years in the security field, both with red team and blue team, kind of done a little bit of everything, incident response, forensics, all that good stuff. But over the past few years, I've really kind of focused in on SIM and detection engineering, as well as threat intelligence. And I'll have Joe interject here and introduce himself.
Thanks for that, Stephen. Yeah, I'm Joe Mastromarino, the Director of North American Sales Engineering here at AttackIQ. Been here since August of 21, over 17 years-ish in security, if I can still do my math right. I had a large background in financial services as well before joining the vendor space here. Like Stephen, a lot of kind of broad-based background in being on the red team, blue team side, a lot of threat hunting experience, a lot of SIM experience, and kind of parlayed that into the purple teaming that we've been doing here at AttackIQ. So really excited to present this information with you here today. So back to you, Stephen.
Thanks, Joe. just to give everybody a kind of overview of the agenda, first I'll introduce Sigma, what it is, what problems it solves. I'll introduce PySigma, which is kind of used to convert Sigma rules into queries for different security products. And then I'll go over Sigma IQ, which is kind of what we've done to both incorporate Sigma into the AttackIQ platform, as well as create an open source library to make your life with Sigma easier and have some kind of cool features and tools with it. We'll also go some advanced use cases with LLMs and chatbots with Sigma rules, something that we have in our open source repository, which I'll mention later. And then Joe will finish it up with a demo in the AttackIQ platform, focusing on how we've kind of integrated Sigma into the platform. So just to kind of preface everything as well, I'm trying to keep this kind of more high level, especially towards the end. It can kind of get sort of technical. I'm not going to go into like code-based examples or anything, but especially towards the end with the AI and LLM stuff, everything, there's examples in the repo that we have, which I'll link in the end. So if you want to see kind of more technical details, you can check that out, as well as you can email me, steven.lincoln@attackiq.com, or reach out to me on GitHub, and same with Joe as well. So just again, trying to keep it more high level. So just kind of introducing Sigma and kind of what problems it solves. Sigma is for detection engineering. And what is detection engineering? Well, what it boils down to is building, testing, implementing, and tuning logic to detect threats in whatever kind of security platform you have. If you kind of go down this road, it seems easy, right? Just detect the bad guys and call it a day. But what you'll soon realize is it's a lot more complicated than that. So, one of the first things you'll run into is, what should I have in place for detecting threats all the time? And then since, there's a evolving threat landscape at all times, how can I keep up with new threats and new detections, things like that? And every security product and SIM has its own query language. So, if I get a detection for Microsoft 365 Defender, how can I translate that to maybe a Splunk or something that I have? And Sigma is kind of the answer to this whole set of problems. What you kind of need is an open source repository of all these detection rules and logic that doesn't really matter what security product you have. You can get rules for whatever and then translate it later to whatever you have. So the Sigma ecosystem, this was released in 2017 by Florian Roth and Tomas Patsky. And it's an open source community focused detection framework. And it kind of consists of 3 distinct things that tie into each other. So first is the Sigma format. And this is the open source schema or kind of rule format that allows rules and detection logic to be shared, agnostic of whatever SIM or security product that you have. And Sigma rules are the actual detection rules and logic that are written with the Sigma format. That can be translated into whatever kind of query you want later on by the Sigma tools. And the Sigma tools are primarily Python-based tool sets that can do the actual conversions of Sigma rules to different kind of product queries. And why is Sigma? Why is Sigma a good thing? Why do we use it at AttackIQ? The main thing is collaboration. It's really difficult to kind of keep up with all the different threats and detections and everything by yourself. So, the more people we have doing it, the better. And Sigma is a great resource for that. It's actively maintained and updated. There's over 450 contributors, including AttackIQ, over 3,000 active detection rules for various platforms and security products and log sources. And there's been over 15,000 rule modifications to the main repository since 2017. And just kind of a anecdotal evidence, whenever there's a new 0-day or something like that, the first place I would check when I was doing more blue team sort of things was the Sigma repository, because there would be detections for it that you could use for threat hunting and alerting pretty much either the same day the 0-day was announced or a few days afterwards. It's also very easy to read and write rules. They're in the YAML format. And since everything's kind of on GitHub, you can use rules from the official Sigma repository or create your own for your own company or your own use cases and have your own private repo. And why we like it at AttackIQ specifically is since all of our content is used to emulate real world attacks. Sigma rules are a great resource that we can use to recommend detection mitigations to our customers based on the attacks that they're actually running that emulate the actual real world adversaries. And then when we run into cases where there might not be a Sigma rule for maybe a new piece of content or attack that we release, we can give back to the community and create the rules from our own testing internally and publish it to the official Sigma repository. So just kind of going over the repository itself, if you go to the repository, which is the link up above here, you go to the main rules directory. What you'll see on the left is the first thing you'll see, which is a bunch of different products that you can find rules for. We're just going to drill down into Windows in the middle right here. Some different categories of rules that you can get. And then on the right are the actual rules themselves in the YAML format. So let's just take this example rule right here. This is what a typical rule would look like. This is for adding a scheduled task with a suspicious parent process. I'm not going to go over every single field due to time. I mean, there's pretty obvious ones like the title of the rule and the unique ID. The really important ones that we want to focus on are log source and detection. So what log source is what you're going to use to figure out, what if you have Windows, you want to use the product for Windows. You're not going to use a Linux rule for Windows detection. And in the kind of backend sort of things, this is what the tool sets use. These fields right here under log source, this is what tool sets use to kind of figure out what fields and mappings to use depending on the original log source and the end of the field names that are specific to their security product. Some of the subfields include category, product, and service. I'm not going to go over every single one, but if you go to the Sigma documentation, they kind of go over this more in depth. And then the detection subfield, this is kind of the most important one since this is where all the detection logic is. So underneath this field, there can be one or more selection and filter fields. Right here, there's only one of each, but selection is pretty much what is the role looking for. And then it uses sysmon field names as kind of the original field names that you can convert later for the fields and values or list of values that you're looking in the detection for. The filter fields are kind of what you want to filter out. So trying to filter out false positives so you don't detect things that you don't want to alert on. And then the condition field is there's only one condition field, and it's the actual logic of combining all the different selection and filter fields for what a true positive detection would be. And then there's a bunch of other fields like false positives and levels more of like the criticality. If you want it to be more of like a, hey, alert me immediately when this triggers for critical level, or more like a low, like maybe don't alert, just add it to some evidence for later on. So now that we kind of know what a rule looks like, how do we convert it to something we can actually use in one of our security products? PySigma is the primary library that kind of drives all the different tools to do all the conversions. The core library is maintained by Sigma themselves, and the community is responsible for creating and maintaining all the different what they call pipelines and backend libraries. What these are libraries that either transform the rule itself to give it different field renames. This is the pipeline. Field renames depending on the product that you're translating to. Backends do the actual, converting it to the query language. AttackIQ actually maintains the Microsoft 365 Defender library, link shown right here in the slide. And to kind of give an idea of how this works, at the bottom, you have a Sigma rule, you run it through a pipeline library, and that will do the field renames and kind of add some more information if needed that the backend can then use to take that transformed rule and then convert it into an actual product query. There's actually some really cool tools online that you can use. One of them is called sigconverter.io, which uses PySigma in the backend. This is a free user interface that you can use online to copy paste a rule, select whatever security product or backend that you want, and it will spit out not only the query for you, the translated query, but also if you're using something called Sigma CLI, which is what you can use in the command line to transform Sigma rules in the command line. It will give you the command that you can run with Sigma CLI as well. So how do we do it in the AttackIQ platform? The example on the right is a scenario that we have for MSHTA script usage. So what we use is a open source library with the link shown here called SigmaIQ. And why did we make this kind of open source library? It's actually a Python wrapper around PySigma. When you use PySigma, it's a great tool, but one of the things that we ran into when we were using it in the platform was you had to install all the different pipeline and backend community libraries to do translations to all the different security products manually. What the SigmaIQ would do for you is just already have it installed once you install the SigmaIQ library. It also has a bunch of ease of use functionality utilities, so you can have minimal setup and coding required. Again, PySigma is a great tool, but however, you can call different functions, whether you have a group of Sigma rules you want to translate or just one Sigma rule. You also have to do some things like creating a specific object, a Sigma rule object in Python, instead of passing in just a Sigma rule string or dictionary or JSON or something like that. And this, you can pass in anything, any kind of data type to SigmaIQ, and it will handle all that stuff for you. One of the other things it does, which isn't in the product yet, is you can supply your own field mappings. So field mappings from the original Sigma rule with like the sysmon field names to maybe a custom field that you have in your security product. It allows you to easily do that as well. Plus a bunch of cool experimental features, which I'm gonna show off now. So recently, last November, we released an experimental update to this library to use LLMs with Sigma rules, because we figured, well, Sigma is a generic signature language, so let's use some large language models, since they're all the craze nowadays, to use it with Sigma rules. So again, we added this in November of 2023, and what we do is use another Python library called LangChain to create some bots and kind of add some LLM functionality. Some of the current use cases that we have examples for in this repository are creating rules, completely new rules with chatbots based on IOCs or like user prompt, automatically translating Sigma rules from the Sigma rule format to whatever kind of output or security product you want with a chatbot, as well as doing similarity searching by creating a vector-based database of all the Sigma rules, which I'm going to go over all that stuff now. Again, kind of trying to keep this kind of high level. I know it's more technical, so ask questions if need be. So starting with the rule translation bot, one of the cool things that LangChain makes it easy to do is you can create a bot and you can tell the bot, hey bot, I have all these Python functions, or maybe I have this Python library. Here's the inputs to it. Here's what the inputs do. Anytime the user asks this specific sort of question, use this Python function with these inputs and take the output and give it back to me. So that's kind of what we did with the SigmaIQ library. We said, hey, create a bot. Anytime that the user wants to translate a Sigma rule, here's the stuff you should use from the SigmaIQ library. So you give it a Sigma rule, whatever output format you want, security product you want, and then the bot will take care of everything on the back end for you and kind of spit out the translated query. So I have just some example output right here. So the question being, translate the following Sigma rule to a Splunk query using the Splunk Common Information Model data model pipeline. And the rule is just a basic who am I detection. And then the answer at the bottom right there spits out, the chatbot spits out the actual Splunk query for you, which is pretty neat. So kind of taking this one step further, one of the things that we could do as well is kind of create a vector database of all the Sigma rules. Since vector database, without going too into details, you kind of create embeddings or something known as vectors based on a series of texts or documents, in this case Sigma rules. And then each Sigma rule has its own vector based on the model you use to embed it. And then you can take user prompts to create embeddings from the user prompts and then search for similar vectors in the vector database and just like magic, out comes similar rules to whatever you searched based on the vectors. So we took this and just did a quick example with it. So the question being, find a Sigma rule that detects modify Windows Defender with PowerShell, goes through, does the embeddings, does the vector, finds a similar vector, and outputs the Sigma rule that's associated with that vector, which is Windows Defender exclusions added with PowerShell, which is pretty similar. One of the other things that we can do with this vector database that we have is use it as context for brand new rule creation. So one of the things SigmaIQ can do is create brand new Sigma rules entirely that are valid Sigma rules, either based on a user's question, context in their question, or if they provide some IOCs or log examples in the chat prompt, the bot can actually take that chat prompt. What it does is it takes that prompt, goes to the vector database, finds similar rules just to use as context, and then we tell the bot, hey, use these rules as context. Here's the Sigma schema based on the Sigma format, and what you know about Sigma already, plus all this context, create a brand new Sigma rule. So again, another example right here, create a Windows process creation Sigma rule to detect certutil.exe downloading a file from definitely-notmalware.com. So again, it takes in that, finds similar Sigma rules, uses as context, and then creates a brand new Sigma rule from the prompt and the similar Sigma rules it found, and spits it out for you in the Sigma format. One of the other cool things is you can chain all these things together, so you can have the bot kind of use multiple steps in sequence. So let's have the bot create a Windows process or create a Windows process creation Sigma rule for certutil downloading a file from definitely-notmalware.com. So the same example as before, but then translate it to a Microsoft 365 Defender query. So it goes through the steps that we just went through to create the new Sigma rule, takes that Sigma rule and says, oh, well, the user has a second part to their question, wants me to translate it to a query. So that it goes through the first example I went over to use SigmaIQ to do the rule translation automatically, and then outputs the Microsoft 365 Defender query from the brand new rule that it created. And again, all of this is in examples on the GitHub link down below. So apologies for not getting too technical into it, but just wanted to give some acknowledgements and references here for special thanks to the Sigma creators and maintainers, as well as all the people that have contributed to the Sigma project. And again, here's some links to some of the repositories that we have, as well as Sigma has for rules and rule conversions. And with that, I think I'll pass it over to Joe for a demo.
All right, thanks for that. And we should probably also address a couple of the questions that are in here as well, Stephen. I think at least one of these I can address in the demonstration. Although the first one, and let's talk about this one together. The question being, how many Sigmas does AttackIQ have against 39 Russian military APT actors that do 3,000 real cyber attacks a year against Ukraine, and about half of that versus NATO countries? I mean, I'll take my first swipe at it, Stephen, and I'd like to hear your thoughts as well. Sure. The first thing I always like to say about that kind of stuff is attribution is hard. And really what this project is truly focusing on is more the common understanding of how do we find all of these behaviors regardless of the attacker group or whoever's doing this activity. So focusing on finding the activity and then doing the attribution later. That said, it would have to be a matter of taking the exercise of looking at all of the behaviors that any given actor group is known to exhibit, and then crossing that with the TTPs that we have Sigma rules for.
Yeah, that pretty much sums it up. I don't have an exact list of how many Sigma rules we have, but all the rules that we have are we just pull from the existing official Sigma HQ Sigma repository. And there are in that repository, you can search through it, and in the description there might be references to APT groups, so you can search for that specific APT group in the Sigma repository. And then, like Joe said, if we have content that is that threat actor uses, we probably have that rule that you found mapped to it. But I don't have an exact number off the top of my head.
Yeah, I always go down to that. It's not really so much a numbers game as, you know, you need to know that you can detect and stop this activity. Well, we'll help you find it. The other one I think can be answered by us here is that Pi Sigma is LGPL, a copyleft license, which makes all of, well, it would be in the scope of what AttackIQ has done here with Pi Sigma. Does that make that entire AttackIQ stack for Pi Sigma LGPL?
Yes.
There you go,
Yep.
simply stated. Anything else to add there, Stephen?
No, it's open source. Feel free to use it. Just keep the license and you're good.
All right. And then the other question, can we use this to build general SIM queries and other product queries? I will answer that in the demonstration here. So Stephen, can you just pass me over the presenter? Thank you, sir.
Yep. Sure thing.
And we go back over to this and then this, and let's go ahead and show my screen. Okay. So now what you're looking at is, and this is the AttackIQ Enterprise platform. Basically what happens with this platform, if you haven't seen it before, is that this is, and Gartner will call us something like a breach and attack simulation platform. We essentially do threat actor, malicious action, malware, ransomware emulation inside of your environment. You can run all of those malicious behaviors without having to detonate any kind of real live malware inside of your environment. Assess the effectiveness of your security controls all the way through. This is the homepage of that platform, and you can see right up at front, here's what's new within the platform. Our adversary research team is constantly working to bring you new content, many times also responding to these high CISA alerts that pop in. And not only do we have these writings, these blog posts that are here, but you'll also see these try it buttons right here, because we've created content that you can actually use within the platform. What do I mean by that? Well, I take a look at some of these other widgets that I see down here, these assets. These are machines inside of my environment that I've installed a small test point software on. Very lightweight, doesn't hook the kernel, doesn't provide protective capabilities. It really just gives us the ability to run all of these tactics, techniques, procedures, anything that we need to do on the host and the network side to be able to determine whether or not our controls could stop and see all the things that we're trying to do. Integrations, of course, the platform can integrate with your SIM, with your EDR, with some of the major firewalls as well, to be able to pull back detections, evidence that we've run these attacks inside of your environment. I'm giving you a very brief high-level overview of this. All of the content that's going to be here, the content library, we have a few thousand different attack scenarios. Think individual actions that are here within the platform that you can take. All of these with full English language descriptions, all of these with the attribution to wherever we can, the threat groups. If there are CISA alerts that are tied to these things, we also tie all this back to MITRE attack tactics, techniques, procedures, sub techniques, even as they're applicable. So all of that is all here for you. We organize all of this content into what we call assessments. The assessment is that piece of ransomware emulation or that threat group emulation, trying to take advantage of something inside of your environment and running that entire attack sequence front to back. Organizing all of that content for you so you can just pick it up off the shelf and say, well, you know what, I want to try to do this play ransomware inside of my environment, pick out one or two of my assets and see how my controls would react. How would my host be able to see and stop this thing that's here? I always like to take these apart because ransomware is still such a hot topic. And what I'll do is I'll show you one of these, this play ransomware. We give you a full English language description of exactly what this assessment is trying to do. And I'm going to get to the Sigma stuff. I'm going to show you exactly how all this ties in, but Let's walk the road with me for a couple minutes. Let's get there. Our adversary research team writes up what this is, when we found it, how we found it, how to easily configure this so that you can run it, any sources that we can cite. And then once I want to start using it, it's a matter of create the assessment, and then off I go. So it's very easy for me to pick this stuff up off the shelf and begin to use it. I'm going to go into my assessment where I already have this. So there's my play ransomware right there. When I want to set this up, and this is what we call an attack graph. This is a visual representation of an attack from start to finish. Now, our adversary research team also includes not only the security experts, logging experts, we have malware reverse engineers on staff. We have lots of people that would understand how this stuff runs from start to finish. Each of these white boxes that you see up on screen here that's giving you a description of a different action, these are all one of those few thousand different attack scenarios that I mentioned. We're going to run all of these things on this box with a little bit of logic in between. First thing it's going to try to do is download a piece of ransomware to memory, testing out your network security control. If you have some type of network-based antivirus, would it stop this malicious piece of software from getting into your network? Then, if it's not prevented, that's what this red line means. If I can do this successfully, let's see if we can take that same piece of ransomware and save the sample to the file system. We are not detonating this malware. We are seeing whether or not we can get it past your signature-based controls on the network and the endpoint. This line here, this green line, means if this one were to be prevented or stopped. Same logic applies with this scenario here. The overall statement is that whether or not you can stop this malicious piece of software from being written into your environment, we're going to move on because we wouldn't predicate an entire attack sequence off of a fairly brittle indicator being that file hash. Next, we move on with some more of the behaviors. And then once we get to service execution, we see a critical node right here that if this scenario were to be prevented, the attack could not continue and we would stop. We would not move forward with any of the other scenarios at that point. And this logic follows all the way through all the different stages of the attack here, the discovery, defense evasion, credential access. We can start to take a look at some C2 and lateral movement, all the way through to when we get to the end stage of the ransomware, where we even go ahead and collect and encrypt files. Of course, we replace everything that we do afterwards. There is never any permanent changes made to any machines. What happens when you run this? Because I've decided I'm going to run this on a few different assets inside of my environment that have the AttackIQ software, also have, in my case, I have CrowdStrike Falcon I happen to have installed here. Once I run this, I'm going to get back a result. I take a look at those results, and this is going to look fairly binary, just by telling me that I stopped the attack or I didn't. I saw the attack or I didn't. Now we can dive directly into any of these assets and see exactly what happened. What's great about this platform is that it is going to show you exactly where you stopped and didn't stop the attack as it went through. A few of these ones right up on top here, this initial access, execution, persistence, you see this one was prevented, and just like I said with the logic, we skipped over this one, writing it to the file system. We continue to move through the process here because the logic said that we can continue moving through the attack. This whole discovery section, a whole bunch of this stuff I did not prevent. And then even leading into, and this is where I stopped the attack right here, my defense evasion and credential access. When I got to the point of dump Windows passwords with an obfuscated Mimikatz, I was able to stop the attack here. This is a critical node and it stopped right here and nothing else executed past that point. So if I'm looking at this, I'm now going to want to say, that's great. Now from here, let me see how I can shift further left as an organization and stop the attack, hopefully a little bit sooner. I'm going to focus my attention in this case on my defense evasion and credential access. I can review all of the results from all of these scenarios, which I'm going to do right here. I expand on that stage of the attack. I can see my dump Windows passwords with an obfuscated Mimikatz was stopped and seen. Downloading the sample to memory, stopped and seen. Used a registry to disable security features, disabling my Windows Defender service. I didn't stop it, but I did see it with CrowdStrike, which indicates to me that perhaps I just need a policy change in order to be able to stop that going forward, even though I do see it. So where I'm going to place my focus right now is on something that I didn't stop and didn't see. Is use registry to disable security features, the real-time monitoring. I can expand any one of these results anytime I want. And this gives me a few key pieces of information. The activity details telling me from the perspective of that AttackIQ test point software, what happened here? What did we do? I was able to check for a key. I was able to write a specific value to a key. So I wrote this HKLM software policies, Microsoft Windows Defender, and it contained all of this. And I created that and placed data into it. So I was able to create it, set it, and then of course, after I'm done, I can roll it back, which is what I always do. My detection details, obviously I had nothing here, which is a big concern for me. The mitigations is what I want to get to, and that's now starting to tie back what Stephen has been telling us about this entire time. How do we pull back these Sigma rules in order to help me with my detection engineering, finding this information based off of the activities that we ran? This section, of course, will give me some general mitigation guidance. That's not what we're here for. We're looking at the detection rules. I'm going to look for one of these in particular, this reg add suspicious paths. And when I click on this one, if you were watching it closely, you noticed it took a few seconds. It was making that call as I was looking at this section of the platform here. And what it is now going to do is provide me with the Sigma rule, with a source to where that rule is. Gives me a description very similar to what we were just looking at that Stephen was showing us in the screenshots that he had. And I can now take this rule, I can copy it, I can download it in order for me to be able to work with it in my other platforms. And if you're looking closely here, there's some more tabs. If I want to take this rule and translate it over into CrowdStrike or Elastic or OpenSearch or Splunk, there are different ways that I can have this information already translated into another platform that I'm using and then be able to continue to use that. This, by the way, this is all built into the platform. So as I'm looking at all of the different behaviors that I'm running over the course of these attacks, this mitigation section is available to me. So I can go ahead and grab the Sigma rule. I can grab the differently translated rules for the products that I need to be able to search on, set up rules for, and in this way, further augment my detection engineering and help find the things faster that I'm really concerned about. So I hope that certainly answers that question, just as a matter of course of me going through this. We continue to work on, to iterate on this, to continue to improve it, but this is a tremendous time save for anyone that's looking for, as I always like to call it, that proverbial so what. So you found a thing, so what are you going to do about it? Well, this is how I'm going to find this thing going forward and then build up my defenses for stopping it happening in the future, if that's indeed the intended outcome that I need there. I haven't seen any other questions come in, but that's the way that we have implemented that at a high level here within the AttackIQ platform. So a very easy way of just taking all that information and marrying it with all the great information you're getting about the attacks that you're running and what you can stop and what you can see. I'll take us through just the last one or two slides that are here for us. As I was going through that demo time here for the AttackIQ platform. There's a few other things. If you have some more questions, please feel free to pop them into the chat. I'm going to have one or two more things to go through here that are always a benefit to you. One of them, of course, being the fact that you had this great education here, and we have lots more education that's available to the entire information security community. Anybody that wants to sign up for it, we have our AttackIQ Academy. Tens of thousands of students on there today. You can take those courses for free. So learning all about purple teaming and MITRE ATT&CK and different ways that you can use things, either whether you're an AttackIQ customer or not, whether it's using the AttackIQ platform or not, There's a lot of great information already there, high quality instructor-led courses, and those can also be used for CPEs. And again, it's free and you can use that for your CPEs. So sign up at academy.attackiq.com. I always like to have that plug in there because it's a great benefit. And one of the reasons I enjoy working here is just like Stephen was talking about us giving back with the with this Sigma project and what we're doing here. This is another great way that AttackIQ gives back to the community. Are there any other questions that you may have? And of course, you can reach out to Stephen or myself about this or really anything else that you need to know related to AttackIQ and especially around this this Sigma project.
Not seeing any other questions in the chat, but maybe we just give it like 30 more seconds just to see. All right, not seeing anything. Thank you, Joe. Thank you, Stephen, for an incredible presentation. And thank you all so much for joining. We'll see you next time.
Thank you, everybody.